Here goes another question. In how many ways can 15 identical chocolates be distributed among 4 children so that each child gets at least 2 chocolates? So we have 15 chocolates, identical ones, and it has to be distributed among 4 children so that each child gets at least 2. Let us enumerate a few valid possibilities. So 9, 2, 2, 2. This is a valid possibility. There are 4 children. Now 6, 4, 3, 2. This is yet another valid possibility. 15, 0, 0, 0. Is this valid? No, because each child must get at least 2. 10, 5, 0, 0 is also not valid because we have 0, 0 here, right? And so on. So you can enumerate several possibilities. But don't you think it is very cumbersome? Here is the importance or significance of generating functions. I can represent this difficult problem using just one expression and you will be able to figure out the answer very soon. Now, the possibilities or the number of ways in which one child can get chocolates can be represented as x square plus x cube plus x to the 4, so on up to x to the 15. Why? Because the minimality condition is that each child must get at least 2 and hence I started with x square. And what is the maximum possibility? I can go up to x to the 15, although a child cannot get 15 chocolates but must get at least 2. I have written x to the 15 here. It doesn't matter, do not worry much. Now, this is for one child. For 4 children, it will be x square plus x cube plus x to the 4 plus x to the up to x to the 15, the whole power 4. Because it is the same for all the 4 children. The coefficient of x to the 15 in the product of x square plus x cube plus x to the 4 so on up to x to the 15 whole power 4 will give us the answer for the question that in how many ways can 15 identical chocolates be distributed among 4 children with the constraint. Now, what I'm going to do is I'm going to take out x square common here. So what does it become? X square into 1 plus x square plus x cube, so on. I'm not going to end it up with a finite term. I'm going to leave it as it is. It will not matter much. You will observe it very soon. The whole power 4. Now, x square to the 4 is x to the 8 into 1 plus x square, so on, the whole power 4. Don't you observe that 1 plus x square plus x cube so on can be written as 1 by 1 minus x. We have seen that 1 by 1 minus x is the closed form of 1 plus x square plus x cube and so on. So, this can be written as x square the whole power 4 into 1 by 1 minus x the whole power 4. Clear? If it is not clear, please rewind the video, play it several times and you will be able to understand. X square into 4 is x to the 8, right? And I'm going to retain 1 by 1 minus x whole power 4 as it is. So, I can write it as x to the 8 into 1 minus x whole to the minus 4. Do you observe that? Because it was 1 to the 4 by 1 minus x whole to the 4. Right? I just took it to the numerator and hence it becomes 1 minus x whole to the minus 4. I have already written x to the 8 outside. I need to find out the coefficient of x to the 15. How do I get x to the 15? X to the 8 is already taken out. What do we have to look for is the coefficient of x to the 7 in the expansion of 1 minus x whole to the minus 4. Because x to the 8 is taken out. It is locked. The only option available for us is x to the 7 because x to the 8 into x to the 7 will give us x to the 15. Do you observe that? Now these are very subtle things. You might have to pay attention and just watch the video once or twice. So the coefficient of x to the 7 and 1 minus x whole to the minus 4. This is very simple. You people know how to do this. Applying the formula, it gives me summation n choose r. What is n choose r here? It is minus 4, or rather I'll write it as 4. 4 choose r into minus x to the r. Right? Now r is 7 here, and hence minus 4 choose 7 into minus 1 whole to the 7. This is the coefficient of x to the 7 here. Clear? Because it was minus x to the 7, I take out minus 1 common, to the power 7 it is. Right? Once you solve the problem yourself, things will be much clear to you. Now, minus 4 to the 7, it is nothing but minus n choose r. How can it be written as? Minus 1 whole to the r into n plus r minus 1 choose r. Right? So, the answer goes like this. Minus 1 to the 7 or minus 1 to the 7 into 4 plus 7 minus 1 gives me 10. So, it is 10 choose 7 into minus 1 whole to the 7. So, minus 1 into minus 1 gives 1. 1 into 10 choose 7. So, 10 choose 7, once we apply 10C7, the formula, we see that it is 10 into 9 into 8 by 3 into 2, which gives me 120 upon calculation. So, we see that 120 is the answer, that is, it is the coefficient of x to the 15. So, in 120 different ways, 15 identical chocolates can be distributed among 4 children, so that at least each child gets 2 chocolates.